Kia ora koutou. Welcome to this video on the structure and bonding of metals. We'll just quickly go over which elements are metals. So we're given this periodic table in the exam at the end of the year, and we just need to remember that anything, if we draw a line across like this, we need to remember where this line would go. Anything on the left-hand side of this line is a metal. So anything in this area here is a metal. Hydrogen and everything to the right is a non-metal. So anytime we see an element, manganese or chromium, those are the metals. So what we're looking at in this video is if we see a metal, so it'll be written like if we had lithium, it would be lithium, and you'll see in brackets an S afterwards because at the room temperature state, that metal will be in a solid state. That's what the S stands for. So if we had solid lithium, what would the structure of that metal actually look like? So we'll have a quick look at what a single lithium atom is from what we know already. So a lithium atom has 3 protons because the atomic number is 3. It has 4 neutrons because the mass number of lithium is 6.9 or close enough to 7. So the majority of lithium atoms will have 4 neutrons. And because the atomic number is 3, when it is a neutral atom, it will have 3 electrons. So what I'm going to do next is show a 2D diagram of what these lithium atoms will look like in their overall structure. But to understand that diagram, I'll just explain a couple of things. So first of all, in the diagram, there's circles with a plus in it. That is indicating the nucleus and the inner electrons of lithium. So we've got the nucleus there and those 2 electrons. So because we've got 3 protons and 2 electrons, this is effectively the cation of lithium. And then we indicate the valence electron. I've used a blue E with a minus sign to show that it's negative. So we'll go straight into that diagram. So we've got these cations here, and we're just using lithium as an example, but this is the same for all metals. So you have the cation of the metal, which is the nucleus and all of those inner electrons. And each of these lithium atoms has got 1 valence electron. And the thing that's different about metals compared to ionic compounds and molecules is that these electrons are delocalized. So delocalized means that they are not restricted to just 1 atom or 1 bond. Delocalized. So that means that these electrons can actually move all throughout this substance here. The thing about these bonds, so the electrons are what hold this structure together. So if you can imagine that it was just cations without the electrons free to flow through the substance, if it was just these positive charges, then all of these positive charges would repel, so the structure would not hold together. So it's these electrons that actually are the glue for this metallic substance that hold it together. So the bonds between these electrons and the neighboring metal cations is what we call a metallic bond. So these electrons there bonding to all of these cations is a metallic bond. A key aspect of these metallic bonds that is really important to the properties of metals is that these electrons, they don't just bond to the cation from which they came. They're bonded to all of the cations that are nearby around them. So the way that this gets described is that these bonds are called non-directional bonds. So, and we'll discover the importance of that when we look at some of the properties of metals. So to give a good NCEA definition, so when we're explaining the properties of any substance, we should always start with a good definition of the structure and bonding of the substance that we're talking about. So I've taken 2 definitions from last year. They've kind of in the 2019 exam they gave 2 sentences, and you could use one or the other. So they've said atoms in a 3D lattice held together by non-directional metallic bonds. So if you're describing a metal, you could use that sentence. Or you could say cations non-directionally electrostatically. So that electrostatically refers to the fact that it's a a bond between a positive charge and a negative charge. So it's cations non-directionally electrostatically attracted to a surrounding sea of electrons. So this is really often how the electrons are referred to, that it's you've got those cations and a sea of electrons. Personally, this definition makes more sense to me, but this is actually the more common definition that I see in the NCEA answer scheme. So we've got atoms in a 3D lattice, so we'll just go back to that diagram there. So the atoms, it would be referring to an atom being, let's say, all of this. So it's kind of referring to the cation and the delocalized electron, and it's saying that they are in a 3D lattice held together by non-directional metallic bonds. So it's saying that there's these atoms that are held in this 3D lattice. So I've only shown a 2D version. So if I was to add in, if I was any good at this, we'd be able to see that there was another layer of cations and all of the electrons flowing through. So it would be like a whole structure. Um, yeah, something like that. I'm trying to make it way worse. So those are the two ways that you could describe the structure and bonding of a metal. So one really common exam question that comes up is this question here. So we've got complete the table below by stating the type of solid, the type of particle, and the type of bonding attractive forces between particles in each solid. So we get given a normally 3 different solids, and we have to work out which one is the metal. So it's actually relatively easy. The metal, we just look at our periodic table and see if you've got an element that's just by itself and it's a metal, then that is going to be the metal that we're talking about. So the type of solid, and we just kind of need to memorize these answers. The type of solid is a metallic solid. So we'll just write metallic there. The type of particle, so there's 2 options that we can write for the type of particle for metals. And that is we can either say that it's made of atoms, so that's referring to the cations and the electrons, or we could say that we've got in the structure it's made of cations and cations in a sea of electrons. So it's kind of, you can either describe this as an all-in-one particle, or you can talk about the cations and the electrons individually. So the answers that you can write, the wording that you can use is simply atoms, which is nice and easy to write. Or you can say cations in a sea of delocalized electrons. So this is going off the screen a little bit, bring it back in. So either or, you need to memorize one of those. Atoms would be the easiest one to remember, but for me, this cations in a sea of delocalized electrons or delocalized valence electrons paints more of an image of it. But whatever works for you, you get the mark for both. And the attractive forces between particles are the metallic bonds. So you just write metallic bonds. So those are the important parts of the structure and bonding of metals. In future videos, we will look at how this relates to the properties of metals, such as their electrical conductivity, their melting point, and their malleability. Thanks very much for watching. Like and subscribe for more Chemistry 2.4 videos. Thanks very much.